Welcome to Real Civil YouTube channel. In this video, we are going to see in simple language what is fault and what is elastic rebound theory. This is our third video. In last video, we have covered plate tectonic theory, and in this video, we are going to cover elastic rebound theory. So, first term that we need to understand is faults. So, what is fault? So, here I have written the term fault is used to describe a discontinuity. It is nothing but a discontinuity within a rock mass, along which movement had happened in the past. Means what? There will be a huge rock, okay, like our lithosphere plates 100 kilometer deep, and they are 500 kilometers or some around that there is their length. So if there is any discontinuity within a rock mass, that is called as fault. In last video lecture we have seen what is plate and plate boundaries. So those plate boundaries also can be considered as a fault. So here it is very important that you understand the meaning of fault. So fault means it is nothing but the discontinuity within a rock mass. And the third point is movement along fault may be gradual or sometimes sudden, thus generation of an earthquake. So movement along this fault means movement of this and movement of this may be sudden or may be gradual. We will see how they move, and because of that there is an earthquake. Now very important 2 points. There are two important parameters associated with fault. They are called, first one is deep and second one is strike. This is very important. First one is the deep and second one is the strike. Next slide we are going to see the picture, but before that we see the theoretical explanation. The strike is the direction of horizontal line on the surface of the fault, okay, whereas deep is measured in a vertical plane at right angle to the strike. So what does it mean? I will show you with the help of an figure. So here you can understand this direction is called as strike direction, whereas perpendicular to this is deep direction. So here you can see this is inclined. This is inclined. So with respect to horizontal, when you measure how much it is inclined, it's called as deep angle. Okay, suppose this is a fault plane, then this will be your strike, this will be your deep. That you have to remember, strike and deep. Now next two important concepts from the fault is, first one is the hanging wall. Hanging wall means what? It is referred to the upper rock surface. It is referred to the upper rock surface along which displacement has occurred, and then other is called as footwall. Again I am going to show you the pictures of hanging wall and footwall. First we will see the definition theoretically, then we will see the pictures. So there are two walls, namely hanging wall and footwall. Okay. Now the last point here is on this slide is vertical shift. What they are saying, vertical shift along the fault plane is called as throw, and the horizontal displacement is termed as heave. It may be asked in your multiple choice question. Vertical throw, horizontal heave. Okay, before going to see the picture of hanging wall and foot wall, we will see the classification. First one is deep slip fault, second is strike slip fault, and third one is the oblique slip fault. Again, we are going to see the pictures when we called it as a deep slip, strike slip, and oblique slip fault in a very simple manner. And these classifications are based on the direction of the slippage. So very important, it depends on the direction. These deep, strike, and oblique these are nothing but the directions. Now whatever we have studied in last two slides, in the pictorial form, in the very simple figure, through very simple figures we are going to understand. Here both concepts are covered, classification of the fault as well as hanging wall and foot wall. So here you can see this is hanging wall. In the definition it has called that the upper rock surface. Okay, but here you see it is moved downward. Why? Because we have shown here A means normal fault. So in normal fault, here hanging wall is moved downward, whereas foot wall is moved upward. Then we called it as a normal fault. Okay, hanging wall is up always at the top and foot wall is always at the bottom. So when hanging wall move downward and because of that foot wall moves upward, then we called it as a normal fault. Okay, when hanging wall moves upward and foot wall moves downward, then we called it as a reverse fault. Then we called it as a reverse fault. And how will you say that hanging wall moves downward or foot wall moves upward? Here you can see this is a fault. Along this fault, with respect to this fault, you can understand that this moves downward, this moves upward. Again here you can see this hanging wall, this fault goes upward, this line is downward. That means this moves downward. Now here you can see they are moved along this inclined plane, right? That means these two are the example of deep slip, right? We have seen that deep slip because deep is inclined, right? This movement is called as deep movement. That's why these two are the example of deep slip. Now here you can see it is moved horizontally, right? So we can say it as a strike because we have seen that this direction is called as strike and the movement has occurred along this. So that's why we can call it as a strike slip. And in final, here you can see it is moved horizontally also as well as vertically also. So we called it as a oblique fault. Here you can see we called it as a oblique fault. So these two are example of deep slip. This is example of strike slip where hanging wall and foot wall moves relative to each other. And in oblique, they move horizontally as well as vertically downward also. So this is how simple the faults and their types. So again in simple language, fault can be defined as a fracture between two blocks. We are summarizing here, and because of fault there is a movement or there is a relative movement to each other. And as I told you, this movement, this vertically downward movement, this vertically upward movement or this horizontal movement or this oblique movement. This movement can occur rapidly, and because of that, earthquake can occur. And that is what elastic rebound theory explains us, that as the plate try to move relative to each other, strain energy gets built up along the boundaries. Means what? Here we have seen that there are two plates, okay, and this is their boundary. But that boundary is not smooth, it is rough. Okay, so one plate may get stuck while moving. Okay, so because of when it gets stuck, the strain energy goes on building along this boundary, and when the stress built reaches the ultimate strength of the rock fractures and releases the accumulated strain energy. Means what? When these rocks moves relative to each other, they may get stuck at some point because the surface is rough, and then because of the movement it's still going on, the strain energy gets built up, and when the stress built up to the strength of that rock, it fractures. We'll see in the next figure. Here you can see when there are fault and there is a relative movement, the strain energy gets built up, okay, and then suddenly the rock slips and tremendous amount of energy gets released and earthquake occurs. So there are few points here, like if the material is strong and brittle, then there will be a large energy released. So in simple word, elastic rebound theory, what it tells, gradual accumulation and release of stress and strain is called as elastic rebound theory. Means what? Here I will draw. I will draw on the next page. Okay. So here you can see gradually the stress goes on increasing and then there is a sudden release. That point is called as point of earthquake. Then again stress goes on building and suddenly it releases the energy when it breaks. So this process is continuous. Because of that, earthquake occurs. So here you can see it is live. It is the example that has happened. Here you can see this is the compound wall. Okay, now you can see the difference. Actually this was a single line, means it was a straight line. But because of earthquake, the land moves and their alignment changes. So this man here showing the difference. That's why this land moves and because of the earthquake. Again you can see what happened. There is a track and earthquake has happened. So this may happen during the earthquake. So I hope the things are clear related to the faults and elastic rebound theory. If you have any doubt, you can comment me. I will surely reply. We have made other videos also. You can see in a series so that concepts will get clear. Thanks for watching. Please like, share, subscribe Real Civil YouTube channel. Thank you. Thank you so much.